Hello everybody and welcome to lesson 3 from our unit 4 graphing quadratics. We're actually gonna be moving away from the graphing bit, as I mentioned previously, and we're gonna be talking about how to solve some equations. So this is really going to be algebra based, and there is a point where will mention something about the general form of graphing and what it means for a point to be on a graph, but we'll get to that. So the first example is just we have to know how to rearrange to solve for the indicated variable. I mean, the indicated variable is just the variable in this question. So here we're solving for a, for example. So again, very important to be following the rules of Bedness. So we're going to try and simplify where we can, and we're going to use that to kind of solve for it. Again, there's different ways you can do it and different orders you can do things. But the first thing I'm going to do is actually, I see a 1 minus 2 inside a bracket, and I'm just going to make that negative 1 squared plus 4. And I'm going to simplify where I can, of course, before I start moving things around to isolate for the variable. So negative 1 squared is just 1, so this is just a plus 4. And now hopefully we can see that I'm going to, okay, different ways to think. You can subtract 4 from both sides, or you can move this negative 4 over to this side, positive 4 over to this side where it becomes a negative 4. So I get a equals 6 minus 4, which is 2. So that's how I solve for the a there. And I'm going to say most of the time you'll be solving for the a in the coming questions. That's just a prediction. That's what you have to solve for. And we're going to try solving some other things. Again, I can simplify some things inside the bracket, so I'm going to go ahead and do that. Negative 1 plus 3 is positive 2. Negative 8 equals 2 squared is 4 times negative 3 is negative 12 plus k. And I'm going to move the negative 12 over to this side where it becomes positive 12. Negative 8 plus 12 is 4 equals positive k. So that's just k. 8k equals 4. And that's my answer. Right, so hopefully we're recollecting how to solve equations from grade 9 or whatever we did this last time. I guess you did some sort of solving in the first unit in grade 10. So even in trigonometry we did some solving. I mean, mostly it was just cross multiplication, so not that much of actual solving. But okay. Again, the same kind of ideas here. 0 equals a 5 minus 1 is 4 squared plus 8. So 0 equals 4 squared is 16. So 16a plus 8. And then hopefully we'll remember that we have to work through BEDMAS backwards. So first we're going to move the addition, subtraction. We're going to move the 8 over to this side where it's going to become negative 8. So 0 minus 8 is negative 8 equals 16a. And again, since we were moving the entire term, we had to flip the sign. If it's positive, it became negative. If it was negative, it became positive, like here. And now we have to move the 16. And in the 16, we're not moving the entire term. 16a is the entire term. We're just breaking that term in half and only moving the 16 to the other side. So it's a numerator-denominator flip. So here 16 is on the numerator, and on this side it goes to the denominator, or it becomes like division. Another way you can think about it is, of course, is you divide both sides by 16. That's much less complicated if you want to think about it that way. And again, different ways to kind of understand what you're doing, but the idea is, in the end, you should get negative 8 divided by 16, which is in fact negative 1 over 2, or negative half, because I'm doing some cross-canceling there. And so this is my final answer. A equals negative half. And like I said, this is very important to know how to solve this, because 99% of the time you are going to be solving for a. Okay, so determine the equation. So we're going to determine the equation in vertex form of a parabola with this a value and this vertex. And now that's super easy, because to write the equation of a parabola, remember, all we need is 3 values. We need the a value, we need an h value, we need a k value. Here we're given all 3 of these values. This is the a value, this is the h value, and that's the k value. So we're going to write y equals a, negative 2 over 3, bracket x minus h. So minus negative 2, I am going to write this extra step, which of course you don't have to write once you get good practice, plus k. So that's plus 3. So I am going to just quickly make this negative of a negative as x plus 2 squared plus 3, which is in fact what it's going to look like. And you'll remember that if it was x plus 2, our h value was negative 2. So you can kind of think backwards here and get to this equation from the h value. So it's good to do that, but hopefully we're seeing how we can graph the vertex here. Now, this is where we're gonna, and it's did I miss part B? Yeah, part B. It's up there. Oops. In vertex point, find the parabola with vertex 5, 8 and passing through 1, 2. So okay, let's see what we're given here. We are given our h and k because that is the vertex, right? We are not given our a value, question mark, a value. We don't know what it is, but we are given another random point, and we're going to talk about that. So we're going to write our equation as we know it for now. We don't know our a, so we're going to leave that as a. X minus 5 squared plus negative 8. So that's just minus 8. Okay, now we don't know our a value. What we do know is that it passes through the point 1, negative 2. And really, you probably have talked about this in grade 9, but we're going to talk about what it means for this point to lie on the parabola. If this point, 1, negative 2, is on the parabola, so on this parabola where the vertex is, 5, negative 8, at some point, the point 1, negative 2 shows up on this parabola. That means if you put this point, x equals 1 and y equals negative 2, it will satisfy the equation. What does that mean? That means this equation, which is, y equals something, will be true if you put x equals 1 and y equals negative 2. Now let's consider another point in this parabola. Let's go back even, and that's just not a nice parabola. Where's a nice parabola? Nice parabola. No, both of these are not nice. I'm gonna go all the way. Okay, let's take a look at. I'm just picking a random parabola here. Let's take a look at this parabola. Okay, now I'm gonna pick again. We're gonna talk about this in the next question, but really, let's say I pick a random point like 2, 0. If I put x equals 2 and y equals 0 in this function, what do I get? I get y is 0 equals 2 squared minus 4. So 2 squared is 4, minus 4 is 0. So this equation is true when x equals 2 and y equals 0. So 2, 0 lies on the parabola. So that's what it means for a point to be on a graph. It means if you put that point, the x value and the y value, into that graph, into that function, into this equation will be true. But let's say I pick another point. Let's say 3, 0. And I say that's the x and that's the y. If I take, 0 equals, for the same equation, of course, 3 squared minus 4. 3 squared is 9. I get 0 equals 5, which is obviously false. So therefore, 3, 0 does not lie on the graph. This graph, y equals this is the graph I'm talking about. Because if 3, 0 does not lie on the graph, that means if I put x equals 3 and y equals 0 into this function, it will be not true, or it will not be, if I put it into the equation will be false. I mean, the left-hand side will not equal the right-hand side if the point does not lie in the graph. But if the point does lie on the parabola or the graph, my equation will be true. That's what you have to remember. If the point lies on the graph or the equation, my equation is true. And that's basically what the idea we're going to be using here, because 1 comma negative 2 lies on this parabola. We know that it lies on the parabola. We're given that in the question. So if we substitute x equals 1 and y equals negative 2, this equation will be true. So that's what I'm going to do. So I'm going to say y equals negative 2 equals a bracket 1 minus 5 squared minus 8. And this is true because 1 comma negative 2 lies on the parabola. So now I'm just going to solve this for a. And this is basically why I said most of the time you will be solving for a. The same, I'm going to simplify the bracket first. This is 4 squared. So negative 2 equals a times 16, so 16a minus 8. Again, I'm going to move the 8 first, so to make it plus 8. So negative 2 plus 8 is 6 equals 16 times a. Divide both sides by 16. Even here, you could have added 8 to both sides, whichever way you want to think about that. And I get a equals 6 over 16. I can cross cancel by 2. So I'm going to go ahead and do that, and I get 3 over 8. So that's my a value. And of course, once you get your a value, you do have to write, therefore the equation of the parabola is y equals 3 over 8 x minus 5 squared minus 8. And again, the final answer that you write will have two variables, the y and the x. That's what your equation should look like. But the a, the h, and the k should be filled in. So, and we see that we filled everything in correctly here. And this is going to be my final answer. This is my equation of the parabola. Right? And the same, okay, so using a formal check, determine if the point 4, 11 lies on the parabola. So first thing I'm going to do is I'm going to say my left-hand side and my right-hand side. So my left-hand side is just equal to y, right? And we know that y here is just negative 11. So that's the extent of my left-hand side calculations that I have to do. My right-hand side is equal to negative 3 times x minus 2 squared plus 1. So I'm going to have to sub in again. So we're trying to determine whether this point lies on the parabola. And we talked about this before. If the point lies on the parabola, the equation is true. If the point doesn't lie on the parabola, the equation is false. So we're going to see if the equation is true or false. Does the left-hand side equal the right-hand side? If it does, the equation is true and the point lies on the parabola. If it doesn't, the equation is false and the point doesn't lie on the parabola. So again, we're going to sub in x equals 4 here. 4 minus 2 squared plus 1. 4 minus 2 is 2 squared. Again, I'm just writing all the steps. You don't have to write all the steps. You can, I guess I'm not going to write all the steps because I'm going to just do 2 squared is 4 times negative 3 is negative 12. And this is, of course, equal to negative 11. And we'll see here that both my left-hand side and right-hand side were equal to negative 11. The equation is true when x equals 4 and y equals 11. Therefore, 4 comma negative 11 lies on the parabola because it satisfies the equation there. So that's the important thing, right? So this is our formal check, and this is how we're gonna do that. Okay, use the following graphs to determine an equation for each quadratic relation. Again, this is it's not that hard. You can do this actually in different ways. I'm going to do it the way you should technically be doing this, and then we're also going to talk about the other ways to do that. Other ways to check if your answer is right. So, okay, first things first, this graph, I am given what the vertex is. So automatically, I'm going to write y equals, a times, so my vertex here is negative 1 comma negative 1. So my h value is negative 1, my k value is negative 1. because my h value is -1, this is going to be an x plus 1 squared, and k value, I'm just going to write the -1 there. Okay, so I still have to find my a. And again, there's multiple, sorry, excuse me. There's multiple ways to find your a value here. I'm going to actually make a prediction and say my answer. If I take a look at the graph, I'm going to take a look very closely at my step values. Look, I'm going 1, I'm going 2 up. I'm going 1, and then my next step is 1, 2, 3, 4, 5, 6. So our regular step values are 1, 3, 5, as you'll remember. But now my step values are becoming 2, 6, and I'm going to anticipate the next one is 10. And I see here that I have multiplied everything, the 1, 3, 5 by 2 to get my new step value. So I'm going to predict that my a value is 2, and I'm going to say my answer is going to look like this. And as for, okay, so technically, you're probably not, I don't think you're going to get marks for doing that. Although I shouldn't say that, I don't know. I'm going to quickly, again, take a look at the answer key to see what kind of work has been done. But theoretically, what you're supposed to be doing is you're supposed to be picking a point on this graph. So let's say this point over here is 0, 1, right? So you can say 0, 1 lies on the graph, right? Therefore, it satisfies the equation. So if you put x equals 0 and y equals 1 into this function, you are going to get a value. It looks like on the answer key you are given you can do it by step values as well. So if you were showing your work here, you're saying the step value is 1, 3, 5. The actual step values are 2, 6, 10. I've multiplied them by 2. And if you show all this work, very important to show work, I think you will get the marks. And it's useful to know this for like multiple choice questions and things like that. But once you know it satisfies the equation, you're just gonna, the algebraic way to do it is just you pick any point. You could pick this point or this point or this point. You can't pick the vertex point because that won't work. You'll just get you'll get a multiplied by 0, so the a will kind of disappear. It'll still satisfy the equation, you just won't be able to solve for a. So you pick any other point other than the vertex, so you're going to plug in or substitute in x equals 0 and y equals 1. So we're going to do that substitution. 1 equals a times 0 plus 1 squared minus 1. 1 equals 0 plus 1 is 1. 1 squared is 1. So this is just 1a minus 1. I'm going to move the 1 over here, make it a plus 1. 1 plus 1 is 2. And as we already figured out from our step values, a equals 2. So that was that. Nice and easy. Okay, so let's do one more question. Again, this is going to be, I think, fairly similar to what our vertex here is 0, 0. So we're going to start with y equals ax squared. Right, that's basically what we're going to start off with. And why am I not putting, again, you can start off with y equals a bracket x minus 0 squared plus 0. Of course, this is going to be like the full form because my vertex here is 0, 0. That means my h value is 0, my k value is 0, right? But of course, this is just equal to that, right? And now again, I'm going to take a quick look at my values here. I'm going 1 and then I'm going, I don't know what that amount is. It's unclear. But I know I go 2 and then I go 1 down. Normally, you would go 1 across, 1 down for a downward facing parabola, 2 across, 4 down, right? That's the pattern that we learned. But here I'm only going 2 across, 1 down. So normally I go 1 across, 1 down. 2 across, 4 down, But in this case, I'm actually going 2 across, 1 down. So what I've done here is technically divided by 4. Yeah. Divided by 4. So hopefully we'll see that that's what we're doing. So my prediction here is that A is going to be equal to 1 over 4, because that's the dividing by 4 part, right? It's x squared divided by 4. This is my prediction. Of course, I am going to check that with some algebra. I'm going to take 2 comma negative 1 as my random point on the graph, because it's nice and, so I'm going to write, 2 comma negative 1 lies on the parabola, therefore it satisfies the equation. Again, I'm sorry about the lag. I have to delete some stuff from my computer. My hard drive is getting too full, I think, and that's why it's lagging so much. But I'll fix that hopefully in the next video. And hopefully you're just like listening to what I'm saying. And so it satisfies the equation, means I'm going to put x equals 2 and y equals negative 1. So negative 1 equals... I actually forgot the negative here because I'm going down. Oops, therefore, 4 down, right? So there should be a negative in my equation. But again, we'll see that when we do the check, right? So a and times x is 2 squared. 2 squared is 4. So negative 1 equals 4 times a. And then I'm going to divide both sides by 4. And so I get a equals negative 1 over 4. Right? And so my final equation I do have to write as y equals negative 1 over 4, or a x squared, which is just substituting the a value back into my original, what I started off with over here, right? So this is the final answer. I think I've already taken a quick look at the homework. I lost your textbook, but I've taken a look at the homework. I don't think there's any difficult questions, and it's very similar to what we've been covering in here. So I will not be going over the homework, but I will invite you, of course, to do the homework, please. And if you have any questions, please post a comment at the bottom of this video. Or like I mentioned in my post, you can send me a snap or contact me or Mr. Chamoli in any one of the myriad avenues that are available to you. So until next video, I will talk to you later. So peace out, have fun, and do your homework, study well, and stay safe, of course, practice social distancing, etc. All right, peace out.